Welcome to our technical channel Ganesh Piping. Before we start this video, I would like to urge you to subscribe our channel and support us. It is very important for us to continue this work that you support us by subscribing to channel and also sharing our videos with your friends and colleagues. You can also support our work by donating to us. We have shared our phonepe credentials in the description of this video. The donated amount is utilized for video editing and video making cost. So we will start this video here. This is the final episode on pipe stress analysis, which we have seen in the previous two episodes. And today we are going to see the stages or the steps that are involved in pipe stress analysis using any of the software, stress analysis software. So moving forward, in the previous episode, we have seen that based on the design basis criteria, we have to prepare a stress critical line list, and whatever isometrics that are available from the stress critical line list, the stress critical line list isometrics have to be identified, and from those isometrics we have to model the line as per the stress isometric in any of the software, like for example Caesar 2 or AutoPipe. So we can see here that the isometric for the line is modeled based on the information from the isometric. So in during the modeling stage, we have to input the properties of pipe, like for example the material of pipe. For if it is seamless carbon steel, then A106, A53, and whatever is the material, accordingly we have to select that code, material code. And then we have to also input the parameters like the design pressure, design temperature, and then we have to define the position of supports so that it will be identified as a node where we will get the load distribution at a particular support. Now this is the modeling stage. We have completed the modeling and inputted all this information. Now the second stage is definition of the load. See, when we are doing the stress analysis, what actually we are going to do is we will physically create a model virtually. That model is created virtually. Even then it is having all the physical properties, the dimensions, and even the material properties of the real world pipe. So now real world pipe and whatever fluid that is inside that pipe, that also the density and all that we have to give, because based on that only we will know the weight of the pipe when it is full, when it is filled with the water. Water we are considering because it is the density is 1, so we get the maximum weight. Now then we come to the load cases, like there are different types of load, like for example a pipe is subjected to its own weight, then when it is filled with the fluid, the weight of that fluid plus the weight of the pipe. Then when the temperature rises, there is expansion, and when there is restriction to expand, then there are thermal loads coming on the piping system, and because of that thermal stresses are developed. So now the pipe is subjected at same time, it has to carry the load due to its weight and load due to the thermal stresses, and at the same time the third load may be the pressure safety valve pop up. So at the same time these three loads are coming on the pipes simultaneously. So whatever stress that is going to produce, that is the principal stress we can consider, okay, which we can call it as a resultant stress. So all these stresses will have an combined effect on the pipe. So these are the different load cases. For example, the weight of the pipe, second, the thermal load, then third, PSV pop-up. So now these are all identified. Hydrostatic load W plus PF. Okay, pipe weight and fluid pressure. Then sustained load, that is weight of the pipe and internal pressure. Operating loads are those loads which are acting on the pipe during the operation of the plant. Weight, thermal expansion and pressure. Experimental loads, pipe thermal expansion, pressure and terminal point displacement. Terminal point displacement means the piping which is connected to two nozzles. For example, these are the end points or the terminals where it is connected. So that particular terminal points will exert force on that connecting part, that is for example nozzle. So that particular load should be sufficient, that nozzle should be sufficient to undertake that load. It should be capable, it should not fail on that. Then comes the occasional load. This load is, as the name implies, are those that do not occur on regular basis but do happen during operation. Okay, occasional loads like we have seen the pop-up pressure safety valve pop-up. Okay, analysis and qualification of load. Once all these load cases are defined, then we run the program and apply a combination of all these load cases, and we arrive to a worst case scenario, and then we do the analysis. The software will give us the results. So at a particular support, that is the node, what is the load, resultant load that is coming, and what will be the analysis output of that process we have undertaken. We will come to know the failure of pipe from overstress or fatigue. Where are the chances where the failure may take place, or if whether with these given load cases and the position of the supports, whether the pipe is failing or not. So if it is failing, then we have to adjust the support, we have to make changes in routing, and so many other things are there. Then second comes leaks at joint. Whenever there is expansion, because of that expansion, the position of the flanges is affected, and because of this expansion, there are chances that the flange joint may get open because of this undue, unproportionate expansion. And the stress analysis will have this flange leakage calculation. From that, we will come to know whether the flanges will leak or not. So we have to design the system in such a way that there should not be any leakage of the flanges. Detrimental loads on connecting equipment resulting from excessive thrust and movement of piping. That we have seen that the terminal points, which are the nozzles, whatever loads exerted on those terminal point should be within the safe limit, within the capacity of those nozzles. Like for example, the nozzle capacity is designed to take 5 tons of load, and if the pipe terminal point is exerting more than that, then we have to minimize this load by changing the support position and so many other actions are needed for that. And the failure of pipe supports, wherever the pipe supports are failing, like for example, if we consider as the guide, rest and guide, and if it is getting dislocated from the structure, then that is a example of pipe support failure. So we have to overcome this. Now This is the final. Once everything, all these problems are solved, then we have to again run the program and get all the entire line systems. When they pass this criteria of load cases, then we have to prepare the stress reports and stress isometrics. Earlier there may be a question that earlier the stress isometric was there, but using that stress isometric we have inputted all the information into the software, and the software has run the program based on the load cases, considering the load cases, applying those load cases on the piping system. And in order to make the system safe, we have to do some changes in the routing of the pipe or even the position of the supports. And so this altered new location of the support and routing and whatever is being uh, identified, and then we have to update our pipe routing and support location as per these new uh, positions which are obtained after qualification of this piping system, stress system. So this is safe. That means the position of the support and line routing is safe because it has passed the stress, and then stress analysis, and then these isometrics are called as the stress isometric, which are extracted from the 3D software. No, from this analysis software we get the stress isometrics. So this is somewhat the nodes 10, 20, 20, 30, and here we are getting the bending stress, torsion stress, these values are there. So from this we can make out that whichever is the weakest, which is having subjected to highest loads. So this is a very short introduction about the stress analysis, what we do in that. So this is all about that. Then final is the load markup at support and submission to civil structure. So we have seen that wherever there is the support location, we have considered it as a node, and there will be a chart uh, wherein we have to mark up the loads that are coming at these supports, which is called the, which we are calling nodes, and this is marked up on the layout, structural layout, and this has to be submitted to the civil and structural team. So what they are going to do out of that, they will come to know the position of the supports, one second, what load is coming on that supports, and they will design the structure which is capable to withstand those loads which we are providing. We means the stress team is providing to the civil structural team. Then pipe span calculations, design of pipe supports, stiffness and flexibility, expansion and stresses, line expansion and flexibility, all these points have to be checked. Then this is all about the stress analysis. It was a very introductory part in all the three episodes. I hope that you have enjoyed these learning sessions. And once again, I thank you all, and happy learning, and have a fantastic day ahead. Thank you.